Slightly later than advertised, but we've had a few technical problems. We're going to start looking at A-level physics. And it doesn't matter whether you're going to be doing OCR physics, whether you're going to be doing AQA physics, or whether you're going to do EdXL physics. They've all got the same basic content in them. And today we're going to start looking at the topic of waves. Now, where do we start looking at waves? Well, a lot of people looked at these at GCSE, and I want to look at these in a bit more detail at A-level. And we're going to go over some of the experiments that you may have had a look at GCSE, but we're going to try and pick up some salient points about waves and investigate them. Right, let's have a go. Let's start off with some waves, and here I've got a slinky, and let's have a look at this in action. Right, slinky, two sorts of waves. I've got the transverse wave, and as you see, if it goes one way it comes back the other. Properties of waves: reflecting. Or I can have the other type of waves, longitudinal waves, and it's not working terribly well on this bit. I can perhaps spread the spring out and you can see it a bit worse, but a slinky is a good way of trying to demonstrate some waves to have a look at what we've got. We've got then simple types of waves. Waves, two forms. We've got them in light, which is going to be the transverse waves, and we've got them in sound, which is going to be our longitudinal waves. And we can look at the various properties of all the waves. But the easiest way is to start going and having a look at some of these. So let's do that. And I've got some equipment I've set up to have a look at the waves in some detail. The first thing we're going to have a look at is looking at the ripple tank. And the ripple tank gives us some opportunities to look at some of the properties of waves. So we've got here our ripple tank, and we'll need to try and put some water in here. And I don't want to put an awful lot of water in. And what I need to do is adjust the feet here. Can I have a bit more water? I think the jug was a little bit too small. Right. Now, let's see if we can get this reasonably level. I still don't think I've got quite enough water in that end compared with this end. We had a few issues trying to get this set up. It'll do. Right, let's look at some of the properties of waves. And if I just make a wave, you can see that it spreads out in a circular direction. Okay. If we get a pipette, it's going to work better than me using my finger. take then some waves here. And we can see that they spread out. Okay, so there's our circular propagation of waves. And we can see some other properties of these, that as I put the wave in there, it does slightly reflect coming back. Not well here, but we can see that to a certain extent. Let's put in a reflector. If I put in a wave now, you can't see this very well. Maybe you can see it reflecting. I'm not really convinced you can see that. Right, okay. So we've got a basic idea of waves we can see with this ripple tank. Simply water, a screen, and we've got a light above it. And we can do more if we start playing around with waves that can be propagated. So I'm going to put in a little holder here. I'm going to put a couple of springs on these. This is going to be way too high to start with. And I'm going to balance on here a heavy weight with a motor. Let's turn this round a little bit, it's going to be easier, and then we'll lower this so that it's just going to touch the water. So getting it right is a little bit of an art. I just want it in enough that it's covering the water, on the water. Right, yeah, that looks about right. And let's start the propagation of some waves. I've got a little eccentric motor here, and we can start to see that it's producing some waves. What I'm going to do, I think, is move the camera a little bit so you can see better. Someone wound it in a bit tight for me, and you can see now better what the waves are actually doing. Now what I need to be able to do is to try and freeze the frame so that we can actually look at some more of the properties of these waves. It's not easy really to see them as they're working like this. Just raising the other end up just fractionally, and I was hoping we were going to get some nice straight waves, but they do seem to be wiggling around a little bit. Now, why is that? Right, let's turn this off for a minute and have a look and see what we've got. Well, we've got the waves, they're reflecting off of the back surface, so we're going to see them as they go along. But if I put one little wave in, you can see that it is dark and light. You can see here some dark bands, especially if I press harder, some dark bands and some light bands. Let's see why these are true. And to do this, I want my set of lenses out, which I can get turns out it's gone. And around the other side there's a box of lenses. Right. I want to look at what a lens looks like. Let's have a look at what a lens looks like. My lens is shaped that it's convex, and we're going to have a look at when I put one of these lenses down what it's going to look like. Found it, Paul? I've got the box down. Right, wrong box. Here we are, another box. And in here I've got some lenses. I've got convex lenses and I've got concave lenses. And let's have a look at a couple of these. If I look at a convex lens here, it's got this sort of shape of a circle, bright in the centre and dark on the outside. So where it's thicker, we've got it being brighter, and where we've got it thinner, it's darker. So we are taking the rays here of light and we're compressing them into the middle, so we're making it appear whiter, and we've got less light on the dark bit, in the shadow if you like, where it's thinner, it's darker. If I look at the same thing with a concave lens, then where it's thinner it's darker, where it's thicker on the outside here it's brighter. So that's what we're going to see with the waves. When we generate a wave where it is thicker it's brighter, and where it's darker it's thinner. And that's the shape of my wave. So we've got a wave that's going up and down, where it's on the up bit it's thickest, it's white, and where it's at its thinnest it's dark. And so we can see some of the properties here of waves. Right, let's see what we can do with a simple idea of reflection, one of the first properties of our waves. We saw it in the slinky, that if I took the slinky and I hold the slinky out and I send a wave one side, it comes back on the other. Then let's see if we can do the same with the water. I'm going to take in a piece of metal and let's send a wave along. And we're seeing the wave coming back. If I do this at an angle, we can see this clearer, that the wave is going off in another direction. Now let's see if we can zoom in on this little bit, and I want to have a look at where the wave is actually being moved. You can see it's going in and it's coming out probably at sort of 90 degrees. Let's put my arm in the way of the camera to make life difficult. And what we're going to do is we're going to put in a wave. I'm going to line up a ruler with the shape of the wave. It's about that. Coming out, the wave is, let's see where it's going. that about right? It'll do. It'll give us an idea. Let's put another ruler here for the reflector. If we bounce the wave, then it's coming in on the sort of a green line, and it's coming out where the pink ruler is. If I draw a line for these waves, these barriers, this line of this waves, then what we can also do is take a normal off of this. So let's try this. And it would be better if I had a piece of paper here to help you. So I'm just going to ruin the whole thing by putting a ruler in there, a ruler in there, a ruler there. We'll do it again. We'll set the wave up. It's about right. So I've got my wave coming in, I've got my barrier here, and I've got my wave coming out. And let's remove these lines and see what we've got. Right, so Paul, I'm just going to bring this down. Paul's going to adjust the camera so you can see this. So I've got a wave coming in, and what I'm going to do is I'm going to try and draw a normal to this line here. So I'm setting my 6 here, and we'll draw in the line of the wave going in. Now if I take this line and I draw in a normal here, I'm going to miss. Right, let's draw another line in. If I draw a line in the normal here, it's going to work. Coming out there. And if I draw in a normal on this one, about there. Alright. My first line did work okay. I'll just put my normals in. Right, okay. So if we have a look at what's going on, this is the wave going in, its direction going in. This is the direction of the wave going out, and this is my normal there. Disappeared to get a protractor because I put it out very carefully and it didn't work. Let's take my protractor, and we can see that we've got an angle coming in of here about 40 degrees, and if we measure the other way, then it's going out at about, according to this, about 48 degrees. And that's simply my bad measurement of putting my line in here, of not getting it quite correct. Did the experiment very quickly rather than taking my time over it, but we've got the angle in is approximately here equal to the angle going out, and in real life we find that yes, it certainly does make the angle in equal the angle going out. Other properties of the waves we can see are quite interesting. Let's look at making my wave go through a barrier. So let's turn this on. Sorry, I've got a camera in the way. Now what we're going to look at is, I want to look at this side of the barrier. And Paul's going to try and move the camera in so we can see this side of the barrier. I'm going to open up the hole very slightly. And now what we can see is the propagation of curved waves from straight. We've got the straight waves, it's going in here and it's curving out. The waves are spreading out, they are being diffracted here. And this is the reason really, when you're standing here behind the door and your mum shouts to you it's dinner time, that the sound will go through here, but it will spread out, and so you will be able to hear it's dinner time. If we do this with an extra piece in the middle, I'm going to put an extra little barrier in. I'm going to do it now, so I've got two little dots, two little holes. Let's make them a bit smaller so you can see. So I've lost which is the one on the camera. So here you can see the barrier I've set up. I've got the barrier with two holes here, and let's have a look and see what's going on underneath. Now we've got two waves being made. One's propagating out there, the other one's propagating out there. And what we've got are lines radiating out. I can see different lines radiating out, and I can also see gaps. This is an interference pattern, so we can see that the wave is interfering with another one. The up is masking out the down and giving it a blank area like here, or the two peaks are joining together and amplifying as we've got here. Right, so we've got reflection, we've got diffraction spreading out, we've got interference. We've got the waves interfering with one another and creating interference patterns. And we can find those sort of things with all types of waves. We can see that with longitudinal, and we can see that with the other type, transverse. Right, let's see what else we can see. We can see some sort of other effects with this, like changing the depth of water, which is changing to refraction. Now what I want to do is have a look at this working slightly differently. So we've got the water working in the ripple tank. We can see that we've got waves, we've got to see how they work, but we can see other mechanisms working, and we'll have a look at another item now. What I've got also is Paul's going to bring the camera back a little bit. I'm running out of room because I've put everything everywhere. I'm just going to move this. I've got this. I'm going to move the wave machine along. Other waves. No, what have we got here? We've got a rod that moves, we've got some eccentric wheels, and we've got some rods. The rod, if you just look at any one particular rod, for instance this one, it only goes up and down. And it doesn't matter whether I turn it one way or the other, it's going up and down. But we can see something about the waves. So let's put the ball here, and as I move the wave, so the ball is actually moving along. And this is about the energy in a wave. Although each of these wave particles, if you like, one of these sort of indicators for my wave, is only going up and down, the energy of the wave is moving along. So this ball is being carried along, representing the energy in the wave. If you look at any particular particle in a wave, for instance the famous rubber duck floating in the pond, then as we turn it, the duck here would only be going up and down, up and down. But the energy of the wave is moving along. We can see that at the other end of this with the longitudinal waves. These are transverse waves. We can see this with longitudinal. It's exactly the same system. We've got these eccentric wheels at the bottom driving these rods up and down, and we can see we've got them close together and far apart. We can see we're moving this energy along from here top to bottom. We've got compressions where the waves are closer together, and we've got rarefactions where the waves are further apart. And we can also see, if we look at the bottom here, Paul's just going to change the camera to look at the bottom. As I move along, you can see the wave moving along the bottom of these little wheels, these eccentric wheels moving along. So we've got here some idea about waves, that transverse waves and longitudinal waves are really one and the same sort of thing. They are both waves, they work in the same sort of way, except they're displayed differently by different types of materials. So sound waves are doing this longitudinal idea of having compressions, pushing the waves together, and light waves and other waves, more like sea waves I suppose, are showing this undulation, this up and down moving along. So we've got an idea there. We can see the waves working in other things, and what we're going to do now is we're going to have a quick look at some of those once I've covered refraction for you. Right, I've got a small piece of acrylic. It's not very thick, and what I'm going to do is I'm going to put that into my ripple tank, and what I'm going to try and do is ensure it's all covered in water. So now this is much thinner. Let's see what happens if we pass a wave over this. Let's look at the side, the edge here, and we can see that the waves, as they go through here, are perhaps becoming closer together, and the waves on the other side are moving further apart. So we've got a difference up here where the waves at the bottom here have been slowed, and we can see a curve here where the waves here are going faster. So when we get shallower, the waves are becoming closer together, moving slower, and when they're deeper, they're moving faster. So we've got some bending of waves, and how this works is easily shown with something like a lens. If I have a lens, and we might be able to see this better on top for a minute. Here I've got my convex lens, thicker the centre, shallower at the outside. This water will be slowed more than the water at either side, so the wave will have a tendency of moving in. And if we now look underneath, you can see that that certainly looks true, that we've got this line moving forward here, reaching a focal point. That's right, you weren't looking at what I was looking at. Let me move the wires out of your way. Right, zoom out a bit. That's right, I'll drop the camera. Right, there we are. So you zoomed out a bit. And what we can see are the waves moving along up towards there. I can see them on the surface. Okay, so we've got the bending of waves. Right. So we've got some idea from this ripple tank of what we're doing. Now, I'm just going to sit down here for a moment and chat to you for a moment, and while that's happening, the ripple tank's going to be moved. That was my hint to my son, who's just going to move the ripple tank just so we've got some space. He's just going to basically unplug it and pour the water out. Yeah, he's managing. Right, okay. Good to see it in the background. Right, okay. Now, what we're going to try... You want some help, don't you? Yeah, okay. Trying to work in my kitchen dining room is not terribly easy for trying to do all these experiments. So let's look at what we've seen so far. What we can work out so far is for waves we've got two types. We've got transverse and we've got longitudinal. We've got then properties of the waves, reflection, and the important bit about this reflection, just stopping something banging, this reflection, refraction, the spreading out, diffraction, and the waves interfering. We can look at more of these in detail later. So we've got our basic properties of our waves. For all waves, as we look at them, they've got certain properties. We've got a distance between one peak and another peak, and we're going to call this the wavelength. From a center point, we've got a measure of how far up or down the wave is. This is its amplitude. And if someone was to sit here and watch these waves go by, we can measure the number of waves passing per second. And this is our frequency. Wavelength we would measure in meters. Amplitude, height of wave, we're also going to measure in meters, and frequency, we're going to measure that in waves per second, or hertz. So we've got this idea of some basic properties of waves. And if we have a look at the waves, we see that if I were to run that little rod going up and down, I could plot where it is at any point. In this wave machine, what I've got is here a measure of the number of degrees that we're going through. So we can start here at 0 degrees, we can rise to 90, 180 degrees, and 270 back to 0. Now if I take that and I try and plot that, and we only look at this first bar moving, you can see all it's actually doing is going up and down. That first bar, it's simply going up and down. And if we plot what that's doing, it's simply starting at points, and at the moment we're going to call this 0, and 0 I'm going to call maximum. Then I'm going to move it to 90 degrees, and it's halfway down. If I move it to 180 degrees, it's fully down. 270, it's on the rise again, back to 360, where it's back at the top. And that's just measuring 4 positions. If we were to measure it more carefully, we would see that in fact this makes sine wave. This is actually the cos, but don't worry about that. It's just a sine wave. So the actual shape of the distance related to the angle is also the shape of a sine wave itself. Now we're going to have a look at some of these waves, and Paul's setting this up. I'm just going to put the other camera on, yes, Paul? No. No? Okay. Just put the other camera on and I'll come and set it up. Right. What he's been busy doing in the background is setting up a signal generator and a loudspeaker. I'm going to turn the signal generator around so you can see that, and let's see what we can do with this. We're going to start with a low frequency. And what I'm going to do is I'm going to turn this up. This is only 8 hertz, 10 hertz. So it's pretty low at 10 hertz. Let's go up to the second level. So let's carry on at around about 10 hertz, about 15. Right, we get to about 30 hertz and this is starting to actually sound like something. At 40 hertz we're hearing more like sound, 50. Take me up to 128 hertz. Let's go to the higher level. Start at 124. We're up into the kilohertz now. And it rapidly runs out of my hearing range, and I don't know about the microphone what it can hear. So there's sound coming out, but what does that look like on the oscilloscope? Well, we're going to have a look and connect up an oscilloscope. Could you go and get me the oscilloscope bits? I forgot them. No, there's a box with connectors. Do you know where they are? No answer. Right, so let's see if we can hook that up to an oscilloscope. And what I can do is I can take these coming out of the speaker and we can have a look and see what it's going to look like on the oscilloscope. Story of my life with wires. What I should have is a little connector. That's the one. And I can connect this to the oscilloscope. And let's see what we get. We could see the shape on the oscilloscope, and as I change this frequency, the notes getting lower, the waves are moving further apart. So low notes. What I need is a better computer oscilloscope for this. So they're quite wide apart. Let's increase the frequency and we can see the waves are getting closer together. Such that you can barely see them, and I can only improve that by changing the time division. On my waves to make them further apart. So this is just adjusting the oscilloscope so I can get different views. This is time per division, so this is every millisecond at the moment. I'm getting down to 0.5, 2, 0.1, making the waves wider. And we get some artifacts formed when we do some of these. Let's take the wave down quite low. And that's at about 68 Hertz. I can stop this, I'm just not bothering at the moment. And at 68 Hertz something interesting happens with this speaker. It starts to move around the ground, over the place. Right, let's turn that off for a minute. And I want to have a look at what's going on, because we can't really see what's going on here. Yeah, we got something on the oscilloscope we can see, but I want to see really what's going on. And I can do that by having a look, by putting a plate on here. And what I'm looking for is my box lid. Because this is about to get messy. Right, so let's have a look what we got. We've got a metal plate on top, and if this now vibrates, we can see the oscilloscope, we can see the frequency, and we can see the plate moving. Now we can make the plate show what's going on by putting something like some salt on there. I'm going to use salt because it's white and it's easier to see. As I change the frequency, suddenly something happens at a particular frequency. Right, let's try it. So at a particular frequency, certain bits of this plate aren't vibrating. We've got this bit here moving really quickly, the salt particles bouncing up and down, but here it's stationary. If I change the frequency, at different frequencies, maybe different bits are going to be moving quicker. Doesn't actually matter if I hold on to it for a little bit, it's still making a particular shape. If I move it, it will still show that some bits are vibrating lots and some bits aren't. And we've got the resonance frequencies of this particular shape, which here is a square. If I did the same thing with a circular plate, we'll see a different pattern. And at certain frequencies it makes a lot more noise, and here you can see we've got two rings as opposed to having the one ring at a different frequency. And you can also see, if you watch the oscilloscope, that it's sort of making different sort of frequency. You can see them on there. Right, so there gives us some idea about some simple properties of waves, and that's the reason I did it in there. So we've got this idea of resonance of waves, and we can somehow see the waves, so we can see what's basically going on. So as an introduction here, we've looked at the wave properties, we've seen it's got wavelength, frequency, and we can see how that we can actually plot our wave, and we can see that we can get another wave formed. Right, so that's got us going on waves. Where do we go next? Well, what we've got to do then is a whole series of different experiments, and all the different books that I've got have got lovely different experiments that we can have a look at to see what's going on with the waves. We can pick up the waves other ways. I could have put a microphone onto the oscilloscope and picked up the loudspeaker to show it's going there. I've done it direct. We can pick up musical instruments. We can have a look at trying to work out the wavelength of a particular note. We can look at distance time graphs and so on. But that is where we're going to finish for today, and we're going to start next week having a look at more about waves. I thought waves was probably a good place to start because it's got so many different bits and pieces and it's on all the syllabuses. So there we are, there's an introduction to waves, and next time we'll have a look in a little bit more detail. So until then, I'll see you later. Take care.